Yes, enantiomers. Enantiomers. Okay, enantiomers are the isomers. Enantiomer are the isomers which are non-superimposable mirror images to each other is called enantiomers. Okay, enantiomers are the isomers which are non-superimposable mirror images to each other is called enantiomers. Okay, for example, this alcohol I have taken, I kept in front of the mirror. Okay, assume that one, it is a mirror. So this is a mirror image. This is a mirror image. So I have taken this mirror image. If I keep on the top of these compounds, if they are overlapped perfectly, that means they are superimposable mirror images. Okay, if they are not overlapped, they are called non-superimposable mirror images. Okay, what I have taken that one? So I have taken one compound and its mirror images. If I keep one over to another, so if they are overlapped perfectly, they are superimposables. If they are overlapped perfectly, they are superimposable. If they are not overlapped perfectly, it's called non-superimposable. They are non-superimposable. Here the same thing here. These are the two isomers. Which are images to each other. If I keep one over to another over, they are non-superimposable. That's why they are called enantiomers. Okay, enantiomers are pair of isomers. Which are non-superimposable to each other. Okay, this example, dextro compounds and levo compounds. Okay, dextro rotation. So this is the one isomers. It is a dextro rotation. That means this isomer will rotate the plane polarized light towards the right side. Yesterday, okay, in just we studied in the optical activity. So in the optical activity, this isomer is rotating the plane polarized light towards the right side. So levo compounds or levo rotation, this isomer is rotating the plane polarized light towards the left side. That's why, so these are the two isomers which are non-superimposable to each other are called enantiomers. Okay, next point is racemic mixture. Racemic mixture is an equimolar ratio of two enantiomers is called racemic mixture. Okay, so an equimolar ratio of two enantiomers mixture is called racemic mixture. Okay, that means one isomers must be present in equal amount, that is 50%. Here also 50% of L isomers. Here the 50% of D isomers. This mixture is called racemic mixture. Definition once again: an equimolar ratio of two enantiomeric mixture is called racemic mixture. Okay, for example, in these two isomers, D isomer is 50%, L isomer is also 50%. That's why this two mixture is called racemic mixture. Next one, racemization. Please, all of you, all points are very, very important. Okay, all points are important. We are going to be learn details in nucleophilic substitution reaction. Okay, racemization. The definition of the racemization is the process of conversion of racemic mixture into the process of conversion of enantiomers into racemic mixture is known as racemization. Okay, the process of conversion of enantiomers into racemic mixture is called racemization. Okay, for example, in some chemical reactions, the two isomers may not form an equal ratio. So, may not form an equal ratio. One isomers may form 40%, another isomers may form 60%. So, in this process, what we are converting? We are converting this enantiomer into 50% by doing some other chemical reactions. That's why the process of conversion of enantiomers into racemic mixture is called racemization. Okay. The definition is the process of conversion of enantiomers into racemic mixture is known as racemization. Okay. Next one, retention and inversion. So very important. Retention. Next first point is retention. Okay. The process in which the relative configuration of the reactants. This is a reactant. Okay. This is a reactant. Okay. Assume that one. It's a one chemical reaction is taking place. This is reactant and this product. Okay. What I am saying that one. The process in which relative configuration of the reactant. Okay. Relative configuration of the reactant is changed after the completion of reaction is known as inversion of the configuration. Okay, so I am discussing first inversion. Okay, now first I am discussing the inversion. Inversion is nothing but what I am saying that one. The process in which the relative configuration or configuration of the reactant changes after the completion of the reaction is called inversion. Okay, so let us take this example of this reaction. Okay, this one is ethyl, methyl, hydrogen and X is there. Here X is replaced with the Y. Okay, this is a certain chemical reaction or some nucleophilic substitution reaction. X nucleophile is substituted by Y nucleophile. Okay, so this is the configuration of the reactant. Here hydrogen is there front line, methyl is there this side, and C2H5 is the above. After the chemical reactions, what happened? Methyl is come back. Okay, hydrogen is also come back from front to back. So that means configuration of this carbon have been changed. This carbon have been changed. In this one, hydrogens and methyls are front side. In this product, hydrogen methyls are back side. So, okay, it is called inversion of the configuration. Next point is retention of the configuration. Retention of configuration. Okay, same again. The process in which relative configuration of the reactant will remain same in the product configuration. The product configuration is known as retention of the configuration. Okay, here also Y is the nucleophile is substituted with the Z nucleophile. So this is a reactant now. For this reaction it is a product. In the reactant, hydrogen and methyl is backside. After the chemical reaction, hydrogen and methyls are the same backside. After the chemical reaction, that means Z substituted. In this case, the configuration of the atoms, hydrogen, methyl and methyl will remain same even after the chemical reaction. Is known as retention of the configuration. Very simple. Inversion means okay, the process in which relative configuration or configuration of the reactant changes in the product, okay, after the completion of reaction is called inversion. The retention means